In this video, we're going to see how we can use a system to approach an application. This is something we already tried with graphing, but we're going to do that again without trying to graph, which sometimes is a much easier scenario when the values get kind of large. But the idea with an application that involves a system is we have to know what our variables are. That's probably the most important thing we can do is figure out what are the two quantities that we're discussing. And these quantities are things that can change where one will depend on the other, um, maybe, or they're just two unknown values that we have. So generally, what we just need to do is read the problem carefully. A lot of times, these variables are going to be mentioned in a question. We'll see that coming up as well. And so the idea here, and overall, when you're solving a system, is if you have two unknown values, you're going to need two equations at least to solve that, and we'll stick at that. So two unknown values will need two equations. In the future, we might have three unknown values that will then need three equations in order to be able to solve. So we're going to write those equations based on the variables we have, and then we'll use our method of substitution to solve the system that we're creating today. So we give you systems to practice these things, but now the idea is we create the system ourselves in order to before we can solve it using the methods that we know. That is the only difference with an application. We're going to create the system before we solve it. And then we'll interpret our answers in terms of the scenario, in context of the situation, as we like to say. So let's go ahead and look at this example. I'll maybe pause the video, take time to read it to yourself. We see that and I apologize, this is probably a rather outdated scenario. That's oversight on our part. We'll maybe update some for some better examples in the future. But we are talking about color monitors here and laser printers, and you notice that we're given different pieces of information. We have the shipment, and for some reason Susan doesn't know what shipment has been put on the dock, but she knows that there are laser printers that cost $700 each and color monitors that cost $200 each. She also sees that there are 30 boxes on the loading dock. Okay. So what we know is the invoice states that the order is totaling to $15,000. So you notice already that some of these numbers are getting pretty large. Trying to graph with numbers this large could be a little taxing. So maybe it's going to be quite beneficial to have a different method to solve this system. But you're going to notice at the end here, there's a question of how many laser printers and how many color monitors were delivered. Okay. And that's kind of the hint for us in this case if we struggle figuring out what it is that we don't know. We don't know, out of those 30 boxes on the loading dock, how many of them are laser printers and how many of them are color monitors. And those unknown values are what we use variables to represent. So when we talk about variables, we don't want to just say laser printers. We know what a printer is. We also know what monitors are. We need to be a little more specific here. It's how many of those things, the number of those things. And so I'm going to define some variables here. It's okay to use X's and Y's. A lot of times in these scenarios, since I'm not graphing, I prefer to use letters that represent the items at hand, so that later on I know that which variable represents my laser printers. And so because L for laser, L can look like a 1, I'm going to use a P for the printer because that's easy to understand. And I'm just going to put that P equals the number of laser printers. And for our other variable, we have color monitors, and I might use M for monitors. And again, the letters do not matter. We just need to label what they represent. So the number of color monitors. Okay. And now that I've defined my variables, I can go ahead and use those, and we'll know that every time I write the letter P, I'm talking about the number of laser printers. And the same for monitors using the letter M. So we need two equations. There must be two pieces of given information up above that we can use. And you're going to see that there are a couple of totals that were given. We were given a total number of boxes on the dock, and we are also told that the total of the invoice was $15,000. Now, generally, good practice is when you have a total, that's what your equation will end up equaling. And so we need to write two equations because we have two variables that we don't know. And in these two equations, we are going to put that they are equal to something. So one total is for the boxes, and then our other total is going to be for the amount of money on the invoice, so $15,000. Okay, so now we have our two equations that are totaling something. We're going to think of how do we get to a total of 30? Well, 30 was the number of boxes that we had. And when we think about that, each printer is going to be in its own box, and each monitor is going to be in its own box. So the idea here is, out of all of those printers, out of all those boxes, some will have printers, some will have monitors. And so if we take all of the boxes for printers and we combine that with the number of boxes of monitors, we should have a total of 30 boxes. And so we get an equation that shows the number of printers and the number of monitors should total to 30. Because if there's 30 boxes, then there are 30 items on that dock, and we know those items are either printers or monitors. So to get a total of 30 items, we have a combination of printers and monitors. Now, something else that we can do that eases the task here, you notice 15,000 is a dollar amount, and we have two other numbers that also incorporate dollar amounts. Generally, those values will all be in the same equation together. So I know that I need to use that $700 and that $200 in this case. So we think about, how do we get that total of $15,000? Well, we know that each laser printer is costing $700. And so the way we can represent that is putting 700 as the coefficient with P, because that says for every printer that was ordered, increase the total by 700. In a similar sense, when we know monitors cost 200, we can use 200 as our coefficient for our monitors, because again, for every monitor that was ordered, we'll pay an additional 200. And overall, if you take the total cost of your printers and the total cost from your monitors, you should get to that total invoice of 15,000. So we have our two equations here, and we have a method to solve those equations. So now that we've created our system, all we need to do is go through those steps that we had for substitution in this case, to determine how many printers and monitors were ordered. So let's go ahead and get that set up. And so as we solve using substitution, my strategy is, let's write the equations side by side. And now we need to solve one of those equations for a variable. I think you're going to agree with me. This is going to take some work to get one of those letters by itself, while the first equation will be pretty basic. And it doesn't matter which one you choose. Maybe you choose to solve for P by subtracting M, which is fine. We could also do the same by subtracting P to get M by itself. But let's just make a decision here. Let's solve for P. And so if we subtract M on each side of the equation, we're going to have P is equal to 30 minus M, which is the same as negative M plus 30. But since we're not graphing, the order doesn't matter. Okay, so with a quick step there, we know what P is equal to, and that now gives us the go-ahead to replace the letter P with the expression 30 minus M. And so we have a value, the variable P over here in this equation. If we replace that with the expression 30 minus M, we are going to have an equation with only one variable. So let's go ahead and try that over here in our second equation. I'm going to do this without the dollar signs for a while. And so let's see. We have 700, and we're going to replace that letter P with what it was equal to in the other equation, which was 30 minus M. And then we have plus 200 M still, and we're still equal to 15,000. Okay, and so once we substitute, we get an equation that just has one variable, meaning we can solve for the letter M in this scenario. Using parentheses reminds us that we need to distribute this value of 700. So let's go ahead and give that a try. And when we distribute 700 times 30, we're going to get 21,000. And 700 times negative M is going to be negative 700M. We still have plus 200M. And we're still equal to 15,000. Okay, so if we continue solving our equation, we're going to combine like terms over here. So we see there's a negative 700M plus 200M. Again, we just combine those because they're on the same side of the equation. We'll still have this 21,000, and then negative 700 plus 200 is negative 500M. And we're still equal to 15,000. And then to solve, we need to subtract 21,000 on each side of the equation, which is going to give us negative 500M on the left side equal to 15,000 minus 21,000 is negative 6,000. And when we divide through by negative 500, we will get a result of M is equal to 12. Okay, so now we know that there are 12 color monitors on the loading dock. And so we get M is equal to 12. And now that we know that, now that we know the value for M, we can go ahead and use it to also solve for P to know how many printers were ordered. And in this scenario, it's not that hard to figure out because there weren't very many boxes, but we take our value of 12 and we replace that here where we see the variable M, and we'll get an equation that reads P equals 30 minus 12, and very simply we're going to get that P is equal to 18. Okay, and in those scenarios that we saw before, this is where we'd stop because we solve for both variables, but in a application like the one we have, what we do is we explain what it is our solution is representing. And so in this case, it's nice that we used letters that tell us what's going on. P was intentionally used to represent printers, while the M was for monitors. And so pretty easily here, we can go back and maybe look at that question, which said how many of each were delivered. And so we can quickly say that there were 18 laser printers and 12 color monitors delivered. And again, that's just the benefit of using variables that represent what was being discussed in the application. And so the only added step to that application is writing interpreting your solution in the end.